Okay, I want you to go to the web browser here, and if you enter the logic.ly here, yeah, you go to the logic.ly. Okay, so when you go to the logic.ly here, that is a simulation a tool. You can work with the logic gate. We learned it for this week. Okay, so basically, when you go to the logic.ly here, now the first option here, you can charge online here. Right, so when you click the try online here, and you close here, everything you can do it with the simulation in the logic gate here. Right, but one thing about the try online here. That means think about this one here, right? I want to test the NOT logic here. Right? So we know that NOT, I can connect it to the line here, and I connect with my switch here. I connect it to the NOT here, right? So NOT off, that means on, right? NOT and on, that means off here. But one thing about the online version here is that I do not have option to save it here. I do not have the option to save it, right? Because in order to get the option to save it here, I need to install the package here, right? So now I do not recommend you to do that. So if some of the activity for this week here, you are required to save it, right? So in order to do that, you go to the logic.ly again. You go to the logic.ly again. All right. Now, I recommend you to do with the free trial here. You have the 30 day. You have the 30 day to trial, right? So when you click on the free trial here, you have some option, right? You can work with the window or you can work with the Mac here. It depends on your computer, right? So if your computer is a window for my computer right now, I go to the window version here, right? So when I click it, I download it here. Download it here, right? So when it's done here, I just click to install it here. Here. Yeah, that's good. All right, so I click the file. That's everything here. I go into this. I install it here. You have the 30 day, right? You have the 30 day to do that. So now you have option to run it now, or you can finish it. You can run it later, right? So I just click the finish it. So when I click the finish, right? When I click the finish here, I think that they have the option to show up in the desktop here. Or if not, you can run it manually. No, right? Go here. So we can go to the search here. You put the logic. Right? That is the one. The app I just installed here. So I click on this one. All right. I set everything here. User here. You click the start 30-day trial. Right? User clicks the 30-day trial here. So you have the 30-day trial. You click on that one, you close this one, and now you see, if I build the logic again, I have a light bulb here, I have not logic here, I connect them together, and I have the switch here, I put it here, I connect it. All right. So now we see, I turn it on, not that means off, right? And turn it off, not that means on here. So we see what happened with this one here. Right? I can save it here. Right? So see, I can save the file. I can put it in the desktop here. Right? Not logic here. Okay, and you save the file, and later on you get the file and you submit the file here. Right? So that's the first step in this module here. I want you guys to download the child version here, and it worked well for 30 days. That's good thing here, right? We only no more than 30 days for this class for the logic gate, right? So you can download it and get ready with the some of the activity right here. And if you have any challenge with the install this one, let me know. Okay. Any question, guys? Any problem with the logic? Okay, let me know. Logic and simulation, let me know. Any problem? No? Okay. So if no problem, let's go with the lecture for today. Today we learn about the numbering system and logic gate. Right? So basically, let's go overview about some of the number system here. So the most common one, the most common number system you do it on daily basis here, it's the decimal system. Right? And the reason is called decimal here because for every digit you have the 10 number here. You have the 10, right? You see, you have the 10 possibility for every digit here. You have everything from, you have everything from, right? Yeah, right? Everything from 0 to 9 here. That's why decimal, right? 0, 1, 2, 3, 4, 5, 6, 7, and 9. Right? So basically, that is the most common number system you use in daily basis, right? The number system here, you normally use its decimal system. It uses as a 10 as a base, right? So we see if you have the number here, it depends on the column position, right? Think about I have 999 here. So basically, this is a one column, right? This is a one column here. This is a 10 column, right? And this is 100 column here, 100 column. Right? So basically, you see, if I have 999 here, I have the three same digits, but the value is not the same, right? The value is not the same. This one, you time with the one here, the value here is number one. This one, you have the column 10, that's why you time with the 10. The value of this one is 90. And this one is 100 column. I time with 100 here, I have 900 here. Right? So it depends. It depends on the position of the number here. They are not the same here. So even that I have the same digit 999 here, but the value is not the same. Right? That's why it uses the base number 10 as the base here. So why the base number 10? You see the base number 10 here because you can see what happened here. You have the 10 base here raised to power 0. You have the 10 here raised to power 1, and you have the 10 here raised to power number 2. Right? You see everything 10 raised to power 0, you have 1. That's one column, right? 10 to raised to power 1, you have the 10 column. 10 raised to power 2, you have 100 column. And if you have 10 raised to power 3, you have 1,000 column. Right? It depends on the position of the number here. Okay? But actually, the number system can use any base. It can be by 3, by 2, by 3, by 4, or whatever. It can be any base here, right? For the computer, you know that the computer here, it works with the binary system here, that base 2 only. And the reason it works by 2 because the computer is consists of multiple switch it here. So you can think about it's simple here. If you have the switch number on here, you can think it is a number 1. And the switch is off, you can think it is number 0 here. And from the combination of the 0 and 1 here, you can do so anything. You can see you can encode it everything in the image file, into the video file or audio file here, whatever it is. Some of the other system you with the computer, they are base 8 and the hexadecimal also. It's a base 15 here. Later on, I explain the concept of the base 8 and by hexadecimal here. Now, for the next thing here, I want you to understand the concept of base and exponent here. Right? The base and its exponent. Any number, right? So the square number, that means the term itself here. So think about that you have the 10 is the base and 2 is the exponent here. You see, 2 raised to the power 2, that means 10 times 10 here. Right? Okay. So when a number is raised to the positive integer number, power it is multiplied by itself by that number of times. I think about if I have the 5 raised to the power 6 here, that means I have 5 times 5 times 5 times 5 times 5 times 5. 6 times, right? So 5 here is the base and 6 here is the exponent. Everything here is about mathematics, about the math here, right? I believe that you know the process of the base and exponent here, right? But you have one exception. You have a sum of the exception. exception here. Right? The first one here. Whenever it's a non-zero number is raised to the power of 0, you only have number 1. Right? Remember that? Think about it. That's why here you have the 10 raised to the power of 0, you have number 1, or even negative 5, you raise to the power of 0, you have number 1. So whatever number it is, if the number is non-zero number here, when you raise to the power of 0, you have number 1. Right? That's the mathematics. Right? And the second exception here, you have the 0 raised to the power of 0. This is undefined. Right? You do not have the thing that in case you have the 0 raised to the power of 0 here. Now we work with the decimal system. You know that the decimal system, that means you have the base. You have the base number 10 here. Right? So when you have the base number 10, the first column here, you have the 10 raised to the power of 0. The second column, you have the 10 raised to the power of 1, and 10 raised to the power of 2, and so on, and so on, and so on. That's why the first column here, right, you have 1 column. The second column here, you have 10 column. The third column here, you have 100 column. 1,000, 10,000, 100,000, million, and 10 million here. Right? That's why you see, I give you the example here. If I have 999 here, you have the 3 is the same digit, but the value is not the same because this one is 1 column. That's why you have 1 here. This one is a 10 columns. That's why you have a 90 here. And this one is 100 column. That's why you have 900 here. Right? So yes, I expect you understand the concept of the base and the position column here. Okay. Now the process works exactly the same with the binary here. The process works exactly the same with the binary here. So in the binary, instead of base number 10, right? In the binary here, instead of base number 10, you have the base number 2 only, because for each digit you only have the 2 number, 0 and 1 only. Right? Number 2 here. So it works exactly the same with the process of the position here, right? So now, if you work as a binary here, if you work as binary number, you see the base here. The base here is number 2, not number 10. That's a difference here, right? And you see, when you have the 2 raised to the power of 0, you have number 1. 2 raised to the power of 1, that means 2 here. You have 2 here, right? 2 raised to the power of 2, that means 2 times 2, you have 4 here. 2 raised to the power of 3, you have 2 times 2, and times 2, you have 8 here, and so on, and so on, and so on, and so on. So for each of the column, you have the specific value here. The first column, number 1. The second one, you have number 2, number 4, number 8, number 16, and number 32, 64, and 128 here. Right? So the process here, you know that when you work with the binary representation, you only have 1 and 0 only. And think about this one here. If I have number 1 and 0, 0, and 1, 0, 0, 1, and 1 here. What do you think? If I want to convert this one into the decimal here, what do you think? What's the value of this one? What do you think? If I have 1, 0, 0, 1, 0, 0, 1, 1 here. Now do it. Do the conversion. Do the conversion here. This is a binary number. And if I want to convert this one into decimal, how I do it? I just add them up together, right? I just add them up together here. So now you see what happened here. This one, I have number 1 here in the 128 column, right? That's why I have 128 here. This one I have 0, that's why I have 0 here. This one I have 0, I put 0 here. This one I have number 1 in the 16 here, that's why I add it to 16. This one I have 0. This one I have 0. This one I have 1 in 2 column here. That's why I have 2. And this one I have 1 into 1 column. That's why I have 1 here. So when I add them up together, right? When I add them up together here, I have 144, right? And 146 and 147. Right? That's the way you convert it here. That's the way you convert from the binary number into the decimal number. Okay? So the process is the same. If you want to convert any base number here into the decimal here, you have to draw the column value here. Right? You have to draw the column value here, and you just add them up together here. Right? Okay. Now I give you another example here. So think about in the case I have number here. I have 1, 0, 1, 1, 0, 1, 1, and 0 here. Now tell me what is the decimal number for this one? You look on this one. You look on this one, you can tell me what is the number. You can use a calculator.
182.
182, right? Okay, 182. So see again, this one you have 128, right? You have 0 here, you have 32 here, you have 16 here, you have 0, you have 4, you have 2, and you have 0 here. You add them up together, right? This one you have 160, you have 176, you have 180 and 182 here. That's correct, right? Okay, that's the way you do it in the conversion from the binary to the decimal here. Right? Basically, when you write the program, it works the same. You have to work with the column value here, and you add them up together. Right? Any question with this one? Let me know. Any question, guys? Okay, so that's the process, right? That's the process here. If you want to convert a binary number to the decimal here, right? Again, you have to work in the column value, right? So we see for this one, right? You see for this one here. What is it? Right? Is this one? Right? So this one here you have 128, right? This one here you have 0. This one here you have 32. This one here you have 0. This one here you have 8. This one here you have 0. This one here you have 2, and this one here you have 0. That's why when you add them up together, you have 180. Sorry, 170 here. Make sense? Okay. So basically, in the computers, normally they work with 1 byte. Byte that means 8 bits here. That's why you see 1, 2, 3. Sorry, you see 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now, yeah, you know the process when you convert from the decimal to when you convert from the binary to the decimal here. But what happens if you want to convert from the decimal to the binary? Right. So now again we work with the byte with 1 byte here, right? So you see if I have 1 byte, right, that means I have 8 bits. Right? So the maximum value here when all of them number 1, all of them number 1 here. 1, 2, 3, 4, 5, 6, 7, 8. So what do you think? What is the maximum number for one byte here in decimal? If all the 8 number 1, what is the value here? What do you think? 255. Yeah, because the last one is number 1, right? Yeah, 255, right? So this one 255, and of course the minimum here, all of them number 0, right? You have number 0. Right? So basically, remember that for every 8 bits here, the minimum value you have number 0, and the maximum value you have the 255 here. Okay. Now think about this one. Think about this one here. If I have number 1, sorry, here, here. If I have number 172 here, right? 172 here. If I want to convert it to the binary, I have to work with the position number here. Right? So now see, I have to work from the left to the right. So in order to make for 172 here, for sure, I need 128 here. Right? In order to make it up for the 172 here, I need 128 here. That's why I put number 1 here. So see, when I have put number 1 here, I have to minus it with 128 here, right? I have to minus 128 here. So what I have the 4 left, right? And I have the 44 left. Right? I have the 44 left. Now, in order to make it up for the 44, I don't need 64 here. Right? That's why I put 0 here. I move to the right here. So in order to make it for the 44 for sure, I need 32 here. Right? That's why I put number 1 here. So when I put number 1, I have to minus it here. 32 here. So I have 12 left. Right? I have 12 left. Now I move to the right. In order to make it up for the 12, I don't need 16 here. That's why I put 0 here. Right? Now, in order to make it up for the 12 here, I need 8. That's why I put number 1 here. So when I put number 1 for 8 here, I have to minus it. I have 4 left. Right? In order to make 4, yes, I need 4 here. So I put 1 here, I minus 4, I have 0 left. So when I have 0 left, I put 0 and 0 here. Right? So that's the process. When you convert from the 172 here into the binary, you're starting from the left to the right. Right? You're starting from the left to the right and you do the processing. Now what happened here? Now let me ask you the question here. Let me ask you a question. If I want to convert the 300 here into the binary, what do you think? How will you do it? How will you do it? Now look on this one. If I want to convert 300 into the binary, how I do it here? And what is the number? What do you think? Yes, you can. No, actually, you can do, but you cannot do it with the 8 bit. In that case, they call it overflow, right? Overflow, because you know that it's 8 bit here. So 8 bit here is only everything from 0 to the 255, right? You cannot do the 300 here. So basically, in order to do 300 here, you need more bit, right? So it normally is a step of the 8 bit here. So in that case, you need 16 bit here, right? You need the 16 bit here. So see, for this one for sure, right? For the 300 here, I need 1 bit in the left here, right? Okay, and everything before that, if now you don't need it, you put 0 here to make it up for 16 bit. Right? That is a kind of overflow. Okay. Anyway, I don't want to go into detail process this one. Now, so you learned about the decimal system, right? You learned about the binary system also. Now we move to the another system. Here is a hexadecimal. Hexadecimal here, hexa, that means 16. That means 16, right? So for 1 digit here, you have the 16 value. So everything from 0, 1, 2, come over to 9. Right? After that, you have A, you have B, you have C, you have D, you have E, and you have F here. So get think about A here, number 10, right? B here, number 11. C here, number 12. D here, 13. B here, 14. And F here, 15. So see, everything from 0 to 15, you have the 16 value here. And that's why they call it's a hexadecimal. Hexadecimal. Okay? Now, let me ask you the question here. Let me ask you the question here. If I need to present, if I need to represent one hexadecimal, right? You see the hexadecimal, you have the 16 value. What do you think? In order to represent one hexadecimal, what do you think? How many bits I need? How many bits I need? In order to represent for one hexadecimal, one hexadecimal digit, how many bits I need? You need 16. You need 16 here. So what do you think? How many bits? Now let me give you some clue here, right? 1 bit you can represent by 1 or 0. That means 2 values here, right? 2 bits, how many values? If you have 2 bits, how many values you can represent? 4, right? You can see here 0, 0, 0, 1, 1, 0, and 1 and 1. 3 bits, how many values you can do? 3 bits. What do you think? 8. So actually the formula here, if you have n bits, so in total you have 2 raised to the power n values. Right? Okay, so that's why I say if you have 3 bits, you have 2 raised to the power 3, you have 8 value here. Now, with the 16 value, what do you think? How many bits? 4. You need 4. Right? You need 4 of them, right? That's why you have 2 raised to the power 4 here, you have 16. So in order to represent one hexadecimal, you need 4 bits. Everything starting from 0, 0, 0, 0 here, it is number 0, right? And you have 0, 0, 0, 1 here, it is number 1, and so on. And at the end, you have 1 and 1 and 1 and 1 here, it is F here. Oh, 50 here, right? Okay. So basically, for the hexadecimal here, they work exactly the same process. Again, you also have to work with the column value here. Column value here. But now, what is the base for this one? What do you think? The hexadecimal, what's the base here? 16, right? Remember, the decimal base is number 10. Binary base is number 2. Hexadecimal here, base is 16. Right? So the column here, you see the first column, you have the 16 raised to power 0, 16 raised to power 1, 16 raised to power 2, and 16 raised to power 3 here, and so on. You use the same process here, right? Remember the base here, number 16, 16, 16, 16, and so on. Right? So what is it? 16 raised to power 0, what do you have? 16 raised to power 0, what do you have? 1. Any number not 0 raised to power 0, you have number 1, right? 16 raised to power 1, what do you have? 16, right? 16. 16 raised to power 2, that means 16 times 16, you have 256 here, right? And this one, 16 raised to power 3, you have the 16 times 16 times 16, you have 4096 here, and so on. Right? Okay, now I'm asking you the question here. What do you think if I have the number 2b here? What do you think? If I have number 2b here, if I want to convert it into the decimal, what do you think? What is the number for this one? In decimal. 2b. If I want to convert it into the decimal, what is the decimal number? Do it by the column here. 2 in 16 column, b in 1 column. You add them up together. Okay, so what do you think? What do you think? What is the value here? Huh? 23. 23, right? So you see, I have 2 of 16. That means I have 32 here. B 11. A number 10. B 11, right? That's why I added 11. I add them up together. I have 43 here. That's the correct one. Right? That's the same. The process here, you have to do the same. Right? Okay. That's the process you do the conversion from the hexadecimal to the binary here. Right? So see, it works exactly the same. with the process here. You have to break it down in the column position. Right? Number 1, number 16, number 256, number 4096, and so on. Right? Okay, now another example here. So if for this one here, I have A and 2 here. So what do you think? What do I have in the decimal? A2 here. What do I have in the decimal? A number 10.
162.
Yes, that's all, right? So A that means number 10 here. So I have 10 of 16, I have 160, right? Number 2 here in the 1 column, I have 2 here, I add them up together. I have 162. That's all. Okay, that's all. Now, what happened? What happened if I want to convert the number 200 here? Sorry, yeah. What happened if I want to convert the number 200 here from the decimal into the hexadecimal? How I do it? I do the same process. I do from the left to the right, right? So see what's it? In order to do the 200 here, I don't need this one. I put 0 here, right? I don't need this one. I don't need this one. Huh? I don't need this one. I don't need this one. I put 0 here. Now, in order to make it up for 200 here, do I need 16? Yes. How many 16? You have to find out, right? How many 16 here? What do you think? How many 16? How many 16 in order to make it up for the 200?
12.
12, right? 12. So what's the 12? A number 10, B number 11, 12, that means C, right? That's why I put C here. C here, that means I have 12. 12 times 16 here, what do I have? 192. Right? I have 192. So see, I only have 192 here. C, that means I have 192 here. Right? So I have to minus it from 192. Right? So I have 8 less. So I put 8 here. That's all. That's the case I want to convert the number 200 in the decimal into the hexadecimal. I have to work from the left to the right. I don't need C here. I don't need it here. I don't need it here. I need 12 of them. That's why I put C here. C that means 12, right? And okay, when I have the C, I have 192 here already, so I have 8 left. Make sense? That's the way you do the conversion here. That's the way you do conversion for the system number here. Okay, so basically for the hexadecimal, right? You have, again, I just review here, for the decimal system, you have the 10 digit, everything from 0 to 9. For binary system, you use 2 digit, everything from 0 and 1 only. Binary, 1 and 0, 1 and 0 only, right? For the hexadecimal here, you have the 16 digit. That's why you have base 16 here, right? And everything you have from everything from 0 to 9. After that, you have A, you have B, you have C, you have D, and E and F. And to make it simple, you can think about A here, number 10, right? Here, 11, 12, and 13, and 14, and 15. So you have everything from 0 to 15. You have the 16 value. That's why they call it the hexadecimal here. Make sense? Okay. Okay, so that is the case here. If you want to convert decimal to the hexadecimal, right? You have to work from the left to the right. You don't need 0. You don't need the 4096 here. That's why you put 0, right? And in order to make it up for 875 here, you need 3 of them, right? You need 3 of them, and you use the percent here, right? You have 3 here. You have the 107 remaining. In the 107 remaining here, you need 6 of the 16 here, right? 6 of the 16 here. That's why you have 11 left, right? That's why 11 left, you put it B here. That's the process. Okay. And now if you want to convert the decimal to the decimal, again, you use the process with the column value, right? 1, 2, 3D here. 1 of the 4096, 2 of the 256, 3 of the 16 here. These that mean 13, right? And you add them up together. 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 You have the 4,669 here. When you convert this one into the decimal. Okay? Okay, so I think you guys can take a short break for 5 minutes and we come back. Okay, let's go on. So you know that I mentioned already, right? So in order to represent a hexadecimal, one hexadecimal, right? You need 4 bits, right? So that's why I see if you have the number 0 here, you have the 4-bit number 0. You have number 1, you have a 4-bit 0001, and so on here. And in order to represent number F here, you have a 4 digit of number 1 here, right? Okay. Now normally for when using the notation, right? Using the hexadecimal notation here, normally it's common to write a long binary number in hexadecimal notation, because you think about if you have, if you want to represent for, A2 here in the hexadecimal, you need 8 bits, right? You need 8 bits because A here you need 4 bits, and 2 here you also need 2 bits here, right? So basically it's very common to write a long binary number in hexadecimal notation here. So if you want to convert directly from the long string of binary number here, you just break it down into group. Every 4 bit you group them together, right? Think about this one here. You group every 4 bit together, right? You're starting from the right, right? You group 4 bit of 1. You group 4 bit of number 0. You group this one 4 bit together, and you group this one 4 bit together. So this one said, this is F here. You have 4 bit of number 1. You have F, right? This one number 0 here. You have number 0. This one you have the number 10. That's why you have A here. And this one you have the 14. You convert it to E here, right? So basically, it's very common to write a long binary number in hexadecimal notation here. And if you want to do that, you just remember you group them into every 4 bit together, right? And starting from the right to the left here, you group them every 4 bit together. Now I move to the section number 2 about the storage, right? You learn about some of the concepts in this class already, right? So if you want to store information into the memory, it can be stored in the RAM or SD or HDD or storage here, right? So basically the first unit here you can use in the storage is a bit, right? Bit, you know that bit is 0 and 1, right? 0 and 1. That means there are 2 possibilities here. The second thing, you can have the byte here, right? The byte 1 byte you have 8 bits. 1 byte have 8 bits. And next on, you can move to the kilobyte. What is a kilobyte? Actually, just remember, kilobyte is not exactly 1,000 bytes. It's not exactly 1,000 bytes. Actually, it is 2 raised to the power of 10 bytes. Raised to the power of 10. So we know that 2 raised to the power of 10, you have 1,024 here. That's why for 1 kilobyte, actually, you have 1,024 bytes here. Not exactly 1,000 bytes. And so on. So on here, you have megabyte. Megabyte, that means you have 1,024 kilobyte, and so on. Right? Use that raised to the power of 10 here. Right? And see, you have kilobyte, megabyte, gigabyte, terabyte, petabyte, exabyte, and so on here. And if you want to see the full range of the storage here, if you want to see the full range storage, you can go to the link I put it here in the slide here. Yeah, so you see, you have a lot of things to do with this one, right? You see, you have a kilo, you have mega, giga, tera, peta, exa, zeta, iota, rona, queta. Honestly, I'm not really sure how to pronounce it here. But anyway, you have a huge range of the measure here. Now, number 4, right? Understanding the computer code here. The computer store every piece of data to you as a set of 0 and 1. You know that, right? Because the computer underlying every computer, it works with the 0 and 1 only, right? So have you ever wondered that? So whenever I press the letter A or letter B or letter C here, how can computer understand it's A or B or C? Have you ever wondered? If you press A, how can computer understand it A? Because it works with the code here, right? So whatever it is, for any character or any special character here, you have to convert it into the code into the computer here, right? And one of the code you can use, it is ASCII code here. The ASCII code here is American Standard Code for information interchange. Right? So think about in the case, right? In the case you enter the what is it? Yeah, in the case here, right? In the case you enter space here. So actually it converts into the binary with 8 bit here, right? 8 bit here, and it converts into decimal number 32. So you understand that whenever you enter the space here, you convert it into the 0, 0, 1, 0, and 0, 0, 0, 0. So every character, right? Every character you enter from the keyboard or whatever, you only have the code to convert it into the ASCII code here, right? And you can see the full range of the ASCII code here. When you click on the link here, and you see I have the full range of ASCII code here, right? So for this one here, you can see what happened with this one here. I think about I have A. Where's A? Yeah, I 65, right? Yeah. You see, I have capital A here. Right? So whenever I put a capital A, right? Whenever I put a capital A, it understands that is a 65 in decimal, and it convert it into the binary, right? And also when I put the lowercase A here, I have this one, right? 97 here. Right? That's the way it works with the computer. So whenever you put any character in the keyboard here, actually that's a process encoded into the ASCII code here. Actually, you have many types of code, but one of the most common one is ASCII code here. Okay. Now, I move to the sum of the concept here because it's already here. You learn about the sum of the concept in the communication also. Again, right? So think about whenever you go to the computer and whenever you do any communication, you need address. And think about if you want to write a letter to send it to your friend, you need address here, right? The same with the computer. If any two computers, if you want to communicate together, you need specific address here. So basically, in the case of computer here, you have two types of address. The first one it is a MAC address here, media access control address, and or is all the concept here. I believe that if you learn about NetD, you have more you will go in detail about what is the MAC address and what's the IP address here. But anyway, I go in the very simple way only, right? So for every communication, you think about if I want to write a letter to my friend here. If I want to write a letter to my friend, right, I need my name. I need my name here. Right? I need to put down my address here. Right? Again, when I send it to my friend, also his name here, her name here, right? Her name, and also I need to put down her address here. So see, in order to send a letter to my friend, I need two type information. The first one is the name. The second one address. So the same with the computer. I try to make it simple here. The same process applies to every computer here. Think about if you want to communicate from this computer here to this another computer here. Again, you need two type information. The first one, it is a media access control here. Media access control here. Address here, it has many names, right? Layer 2 address, a physical address, or data link address, and so on here. It represented by 12 hexadecimal, and it's unique, globally unique. Right? So you can check it here. Right? Now you can go to your computer. Every computer, if you want to go to the network here, you need to have the unique MAC address, and you can go to the command line here. You will put the CMD here, and you can check it by the command IP config and space and shut all here. Okay. So when I put on this information in your computer here, you can see, right? You can see what happened here, right? So I go with my network interface card here, right? So see, I have this is my physical address here or MAC address. So if you look on this one here, if you look on this MAC address here, that is MAC address or layer 2 address here, and you can see for this one. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I have 12 of hexadecimal. I have the 12 hexadecimal. So what do you think? If I have the 12 hexadecimal, how many bits it is? How many bits? That's the MAC address. I have 12 hexadecimal. How many bits? I'm asking you. You learned it already. 1 hexadecimal, you need how many bits? 1 hexadecimal, you need how many bits? 4, right? You need 4. So if you have the 12 hexadecimal, how many bits? 12 times 4, 48. Right? So basically from the MAC address here, you have the 48. So how it works here? For every computer, if you have the network interface card here, in order to go to the network, you need specific and unique, globally unique MAC address. And it breaks it down in 2 parts here. The first one is the vendor ID. And the second one, you have the serial number in that ID, in that vendor. Right? So we look on this one, I can tell it is manufactured by Dell or by HP or by Cisco, whatever it is. Right? So think about this one here. Right? Think for my network interface card here. Right? I can copy this one. The first 6 digits here, that means the 24 bits. It is a vendor ID, right? So I can copy this one. I can copy this one. I can put the Control C here and then go to the OUI lookup. OUI that means you look up. Yeah, so I paste my MAC address here and enterprise here. So now it tells me this is a manufacturer by Dell here. Right? So basically for MAC address, you have a 48 bit. Right? For MAC address, you know that you have the 48 bits. 48 bits. It represents by 12 hexadecimal. Again, it breaks it down into 2 portions. The first 6 hexadecimal, it is a vendor ID. Vendor ID. The second 6 hexadecimal, it is a serial number. Sorry, serial number. So when you combine the 6 hexadecimal here of the vendor ID and the 6 hexadecimal here of the serial number, it is globally unique. never ever have any two computer with a two network interface card has the same MAC address. It globally. Okay, and remember the MAC address here. MAC address here, they are encoded into the network interface card. And that means you are not able to change. It always stays the same, right? So we think about this here. I have the computer here, and when I bring it home, the MAC address stays the same. It always stays the same because it encodes into the network interface card here, right? So this, you can think the simple process here. You can think about this one. You can think about the same simple process here, all right? Where am I slide? Here, this one. This one. Here, you can think about this one. So I want to make it simple. I want to make it simple by the comparison here, right? So you can think about the MAC address here. You can think about the MAC address here. The same process with my name. It always stays the same, right? So I'm live here in the Lafayette, or I moved to Chicago. When I move back to my country, Vietnam, my name stays the same, right? Stay the same here. Now that's the first thing. Remember about the MAC address here. MAC address, the media access control, right? You have the 12 hexadigit, yeah, uniquely identified here, right? And it's a burn-in address. It's a network interface card here. Cannot be changed. It cannot be changed here. Right? It cannot be changed here. Now, the other thing you can think about the MAC address here. The same with information of the name. Right? Even as she right now, she lives in the Texas here, but she moved to the California, or she moved it to the Arizona. Her name always stays the same. The same to my computer. I bring it here or I bring it to my home. It always stays the same. Make sense? Now that's the first one. The second one here, in every communication, you need another information in address. So that is the key of IP address. That is the key of IP address here. The IP address is uniquely identified assigned to the network interface, to the network layer, and IP address is changeable. Remember that, changeable. Think about this one. My friend here right now, she lives in the Texas here, but what happened? She moved it to the Arizona. What I got it? That is the IP address. So if I work with my computer right now, right? You see my computer right now. You can see what is my IP address here. I see what is my IP address of my computer right now. I have the 172.16.030. This one, sorry, this one here. 172.16.254.11 here. But when I bring this computer back to my home, it's not the same anymore. Right? Because it depends on the networking. Right? Okay, so I try to make it simple here for every communication, right? So for every communication, you need to type address here. The first one is a MAC address here. You can think about that's your name. The second one, the address, you can think about the IP address. The IP address here, you have the two versions. You have two versions of IP address. The first one is IP version 4, or the second one is IP version 6. IP version 4, you have the 32-bit in total. In 32-bit. And you see, with the IP version 4 here, right? IP version 4 here. 32-bit. That means you have 2 raised to the power 32. You have about 4 billion total addresses. And nowadays, it's not enough, right? You can see that each of you have many devices, and each of them they need IP address. So that's why they come up with the idea of IP version 6. IP version 6, you have 128 bits. You have 128 bits. You have raised to power 128 here. You have huge range of IP address. And remember, in the case of IP version 6 here, it represents my hexadecimal. It breaks it down in 8 groups. 1, 2, 3, 4, 5, 6, 7, 8. 8 groups, and each group you have the 4 digits. You know that 4 digit hexadecimal, right? That means you have the 16 bit here. And time with 8 group, you have 130. Okay? So that is some definition about, I don't want to go into detail, because if you want to go in detail, actually not this class. You have to learn about the NetD here. Network infrastructure. I think about NetD 104 or NetD 109 here. Now, anyway, I go with another definition here. Another definition about the IP version 4 here, right? So again, in the IP version 4 address, right, it break it down into the network portion and the whole portion. You have the 32-bit of IP version 4, right? You have 32-bit here, IP version 4, and represent by it can represent by the binary or by the hexadecimal. Sorry, by the decimal. You convert it into the decimal here, right? And you have the dot here. You have dot here. So in the case of IP version 4, again, it breaks it down into two portions. You have network portion, and it's a whole portion here. So every computer on the same network, you have the same network portion. And and in order to identify the network portion here, you use a definition of the subnet mask. The subnet mask, again, they have the same format with the IP version 4. You have the 32-bit. But every bit in the subnet mask here, in the network portion, you have number 1. And every bit in the whole portion, you have number 0. You see, in the subnet portion, every bit in the network portion, you have number 1. And every bit in the whole portion, you have number 0. Right? So by looking in the subnet mask here, you can tell how many bits here in the network portion and how many bits here in the whole portion. Okay? And the reason you know that because if the two computers on the same network, they have the same network portion. That's why you see right now, if you look into your computer, right? I believe that if you look into your computer here, every computer right now, because we are now in the same network, right? We are now in the same network. And it's like over here. See, for this one, right? I'm talking about the guys in class here, not the guy online, because you are not on the same network with me, right? So I believe that every one of you here, if you look into your network, right? If you look into the network here, you have the same portion here, 172.16.0, because we are on the same network right now, right? You are on the same network, that's why you have the same network portion, okay? And in order to determine the network address, you use an AND logic here. Right? You ANDing every 1 and 1, you have 1, 1 and 1, you have 1, and 1 and 0, and have 0 and so on, in order to determine the network portion here. Now, I think let's see. I move to the logic here, because we learn a lot of things in the logic in this class. Some of the propositional logic. The first one is a negation here. Negation, that means not. So when you see the negation, that means whenever you hear the word not here, I think about it's not raining. Right? See, it's not raining here. You hear the not, that is a word with the negation, not here. Right? So what is it? When you have the not logic here, right? You have the not logic here. If you choose, you opposite it. You go to the 4 here, right? And you have the 4, you opposite it. You have the 2 here. That's all. Not that means you reverse it. Right? That means if you have number 1 here, you reverse the output number 0, and you have input here number 0, you reverse it, you have number 1. Right? So now I want you to open your logic simulation here, so you can do some of the simulation with this one. Now you open your logic here, continue child, close this one. You can open it. So we do some of the activity with the logic gate here. Now I want you to drag and drop the switch here. I want to drag and drop switch here, right? So I can put the switch. Put the name here. Or I can put some of the text here as a switch. Like. So you know that for the switch, right? The switch, that means you have the 2 status, on and off, right? The same as this one here. You have that. Every switch you have on and off. Right? On, that means like on, and off, that means you have no electric to go to, right? So whenever you put on, you have electric to go to. Off, no electric, right? So That's the process when you work with the logic gate here. Right? You drag and drop the switch here, and you see you have two status here. You can put it on or off here. That's on here. You have electricity going on, right? And this one is off here. And now you work with the NOT gate. You know that NOT gate here. This is a NOT gate. NOT gate that means everything in reverse order, right? That means if you have the on, you go to the NOT, it is off. Right? And if you off, you go to the NOT, you reverse it, you have on here, right? So you can connect them together. You see, you can connect them together here. You drive, put it here. Now I want to test it with the light here, right? So I have light from here. I connect it to the NOT gate here. I connect it to the NOT gate. I put it here. So we see, right? See what happened here. Right now, you see, what is the status of switch here? On or off, on or off. So on or off. Sorry, off, right? Yeah. So off here, see, off, but the light is on because it's reversing. Now see, that is not logic. If you have off here, after the NOT, you have on here. That's why you see the light on here, right? But now if I turn on the switch, click on this one here. You turn on the switch. See, if I turn on the switch, if I turn on the switch here, you see, turn on that means I have on. Turn on that means I have on here. But after the NOT, I have off. You see, the light is off here. Right? So that's the not logic. Not logic, that means reverse only. That's a reverse. That's the process of reverse. If you have number 1 coming in, you have 0 coming out. If you have number 0 coming in, you have number 1 coming out. Right? Or if you have a 2 here coming out, you have 4. Right? Or if you have 4 here coming out, you have 2. That's all. That's the process of reverse. Opposite. Make sense? Okay. Yes, so you can put some of the text here, right? If you want, right? So here, I can put here. You put it not and this one is light. Okay. So basically, that's the process of the not. Right? Not is everything about opposite here, right? So think about in my example here, right? If you look into the slide here, right? Whenever you hear the word not, you use the not logic. Right? That means reverse here. So think about it's not raining. I think about this one here. I change this one. Right? I change my logic. Now it's raining. I change it. Here's the raining. Right? Right? This one. So, sorry. Not raining. So see what happened here, right? If raining now, right? I go to the north, you have not raining, right? And if it's not raining now, I go to the north, it's raining now. Okay, that's the process of the north here. The other logic here, some of the other command here is the and. And whenever you hear the word and here. So what is and? And that means you only choose when both of the inputs is coming through here. Right? So we see for this one here, that is called the truth table here, right? So we see I have 2 and 2, I have 2, right? But in any other case, I have 4 here. So we see what happened here. It's raining and cold. That means both at the same time, right? It's raining and cold here, right? Okay, so we can do the same process with the logic here. Think about this one, right? Think about the process output of the raining and cold here, right? You see, I need to use the AND logic here, right? I need to use the AND logic here, so I delete here. I have to use AND, yeah, and that is AND gate here, right? I drag and drop on this one and get here. Now, see, in the AND here, you have some option, right? You have the 2 input here, or you can you can have more than 2 input. You have 3 or 4 or 5 here, right? But anyway, for this one, to make it simple, I work with a simple logic. I only have the 2 input here. So that's the end, right? So I can have you can think about this one here. I have the switch here. You can think about this one. I put this one. It is raining here, right? Raining here. Do the other one. I do the other one. This is cold here, right? I put this cold here. And now I go to the AND logic, right? I go to the AND logic. You know that the AND logic here. And the output of AND logic is true. Only one order to input true, right? So we see I connected to the line here and can observe with the process here, right? I connected to the lines. I connected to the lines. I connected to the line here. So now we see right now. If you look on this one, it's raining or not? Right now, it's raining or not, right? So I have 2 input here. Right? I have rain, and I have cold here, and I have output here. So see, if you look in my diagram here, it's raining or not? No, because the switch is off, right? And it's cold or not? No, right? So you see, if I have the 4 and 4 here, I have 4. Right? Sorry, I have 4 here. Now see, you can observe it here. Now, if I turn on the rain here, if I turn on the rain here, I turn on the rain here. See, if I turn on the rain, that means rain is true here, right? Rain now is true, and the cold is a 4. The line still up here, right? And now what happened? What happened here? If I turn off the rain, if I turn off the rain and turn on the cold here, right? So see, the line still off here. The line still off. So this one 4 and this one 2. You have 4 here. And now the line is going on. Right? The line is only going on only when both is raining. When it's both raining and cold here, right? So see, that's the AND logic. The AND logic here is output of the output of AND logic is true when the input, all of them, they are true. Right? That is the AND logic for this one here. Right? So you see the process of the combination of the output here, right? Of the output here. Right? So you see the output here is true only when the condition input is true, and in any other case they are false here. Right? That is the case. That is the case of the that is the case of the AND logic here. Right? Okay, now I want to do it as the one here. It's OR logic. So what is the OR logic? OR logic here, when you heard the word OR, right? When you heard the word OR here, so it evaluates to true if any input is true. So whatever it is, if you have at least one input is true, for sure the output is true, right? For sure the output is true. So think about example here. It's raining or cold here. So if it's rain, it's correct, right? Or it's cold, it's correct. Or it's rain and cold, it's also correct, right? It's only not correct if they are not raining and they are not cold. It's not correct, right? Okay. So basically, if you work with the OR condition here, right? So you see, if you work with the OR logic here, I just change this one. I delete this one here. I don't want to work with AND here, but now I want to work with the OR logic here. Right? This is OR. I change it to OR here. Change it to OR. And I turn it off. Turn it off. See, when I connect with the light here, connect with the light here, connect with the light. Now see, right now the light is off because it's not raining, it's not cold here, right? But any input here, if it's raining, the light for sure is on, right? So see what happened here. If it's raining here, right? If it's raining here, I have on here. On here, right? If I turn off the raining, it's off again. But I turn on the cold here, it's on here, right? And if I turn on both of them here, right? So basically for the OR logic here, if you have one input, it's true, the output is true for sure, right? So we have rain here, right? You have cold here, and the output here. Now we see, if I have 4 and 4 here, I have 4. But if I have 2 here, I have 4 here, I have 2. If I have 4 here, I have 2 here, I have 2. And you have the 2 here and 2 here, I have 2 here. Right? So see, the output here is 2 when at least one of them 2. They said it's only off when all of them off. They said that is the case of the OR here. Now the other logic, the other logic you learn it is in the case of the exclude OR here. Okay. The next one you learn about the exclusive OR here. Exclusive OR, and each of them, you remember, each of them they have the symbol here, right? That is the case of not. That's the case not here. The symbol here. The other one is N here, N here, right? That is the case of N. And the other one you have OR here. That is the symbol you represent the OR process. And this is an exclusive, exclusive OR here. So when in the case you use the exclusive OR, that is evaluate it true if one and only one of them true. Remember that one and only one of them true, right? Okay, so you use when you heard the word either here. Think about that is either went to the store or gym. Now he cannot go to the store and gym at the same time. That's why, right? That's why if you go to the store and the gym at the same time, you have 4 here. Right? But any one of them, right? He can go to the store, it's 2, or he can go to the gym with 2 here. Right? So that is case. You see, if only one of them is 2, you have on here, you have 2 here. That's why you see, if you look into the truth table here, you have see, if only one of them 2, you have 2 here. Only one of them 2, but all of them 4, you have 4, and all of them 2, you have 4. Make sense? And you use in the case of either here. Right? So to make it simple, you just remember when you use it here, right? You use a not when you want to reverse it. You use an and when you use an and here, right? You use an or, you have one of the possible 2 here, and you have exclusive OR. You have to be very sure in the case you work with the logic gate. So yes, that's what you learn about the logic gate. I show you already, right? I show you already when you learn about the logic gate. Logic gate, you can think about in the case computer, right? It's recognized only 2 states, or on and off here, right? On, that means you have number 1. That means when you have the high voltage running out, right? You have the low voltage, that means you have 0 here. And the logic gate is a device that performs a logical operation on one or more binary input and produce a single binary output. Remember, you can have one that in the case of not here, right? In the case of not, you have one input. In the case of and or exclude or, you have more than one input. But remember, the output is only one output only. Make sense? Okay. So basically for basic gate and circuit, right? The circuit is a combination of multiple logic gates. Circuit is a combination of multiple logic gates here, and they can do many things. They can do arithmetic, like addition, subtraction, and so on. They can do the comparison here, greater than, less than, or equal. Also, they can work as a memory storage. So basically for the logic gate, that's why it's very important to understand the concept of the logic, because they can do everything. They can do everything with the mathematics here, right? And arithmetic, addition, subtraction, and so on. You can do the greater than, less than, and equal. And you see, that's the case here. That is the case if you want to do the comparison. If you want to do the comparison with the logic gate here, I think about I have input, right? You know that the input only 1 and 0, right? So if I have 1 here and 0 here, I can do it here. This is the one who lie up here. If I look on this one, okay, and so on, you can do it with the that is a 1 bit magnitude compare here. Yeah, I have this in the slide here. If you want to play around with that, you can download that file. You can see you can do the comparison with the logic gate here. Okay, now all of the process here, right? All the process you did so far, I mentioned here. The code is a truth table. The code is a truth table here. The truth table is very helpful in the case you look in the input and output here. Right? So if you look in the not logic here, you only have one input and you have one output. Right? And if you look in the truth table for the AND logic here, you have the 2 input and you have one output here. Right? And for the OR logic or exclusive OR here, but actually in the live, right, you can have the multiple combination of logic here. I think about the case here, right? Think about I give you the example here. It will be happy day. It is a sunny day, and I can swim or I can play pickleball here. So see, this is a combination of AND and Y and OR here. It's not only AND and OR here. Right? So in real life, in the life here, sometimes you have the combination of multiple logic gates here. Right? So in that case here, right, it should be better you use the truth table to solve the problem. So what is truth table here? How can you build the truth table here? The first step here, you have to determine the number of rows you need here. It depends on how many conditions you want. Right? So see, if you have one variable, 2 raised to 1, you have 2 output. The case of not, right? The case of not here, you see the case of not, you have 1 input and you have one output here, right? So see, if you look in the case of not here, if you look in the case of not, right? See, if you look in the case of not here, right? The not here, you have 1 input, right? The case of not here, you have 1 input and 1 output. That's why you need 2 rows. You need 2 rows here because 2 raised to power 1, you have number 2 here, right? Okay. Now, in the case of AND and OR here, right? In the case of AND and OR, you have 2 inputs. That's why you need 4 rows, right? 2 raised to power 2 here, you have 4 rows here, and then so on. If you have 3 inputs, how many rows you need? If you have 3 inputs, how many rows you need? Tell me, guys. If you have 3 inputs, how many rows you need in the truth table? Please stay focused here. Stay focused here. Yes, 2 raised to power 3, you have 8 rows here. That's the way you work with the truth table. Right? That's the way you work with truth table here. Now, think about this one here. Right? It will be the happy day. It is a sunny day, and I can swim or I can play pickleball. Right? I can swim or pickleball. So I have 3 variables here. The first one, sunny day. It's sunny day or not. The second one here, I can swim or not. The third one here, I can play pickleball or not. So in this combination, I have 3 variables. Right? I put it here, 3 variables: sunny day, swim, pickleball, and now the last thing, the happy day here is output. Right? Everything here, they are input. Make sense? I have 3 variables. That's why I have 1, 2, 3, 4, 5, 6, 7, 8 of them. Now try to do it. Let me do it here. If I have 4, I have 4. I have 4 here. What I have? What I have? I'm a happy day or not?
False.
4. Okay. What I have here? 4. If I have 4 here, Okay, I have 4 here. I do it here. 4 here. 2 here. So for this one, I have 4. I have 2, 4, 2, and this one I have 4. I have 2. I have 4. I have 2. I have what's it? Yes. So I have 4. I have 2, and I have 4. I have 2 here. Good. Now, if I have 4, and 4, and 4 here, I have 4, right? How about this one? I have 4, and 2 here. What do I have? What do you think? I'm happy or not? Why? Why is 4?
It needs to be a sunny day.
Yes. At least you need to be the sunny day here, right? So see, if you do not have the sunny day, for sure, everything here, you have 4. Right? Make sense? Now, if I have 2 and 4 and 4 here, what do you think? I have happy day or not? Why?
No.
Because I cannot play, I cannot swim, or I cannot do with the pickleball here, right? So 4. What do you think about this one? If I have the sunny day, I cannot swim, but I can do the pickleball. Do I have the happy day? Yes, right? Okay. So I have 2 here. If I have the sunny day, I can swim, but I cannot do the pickleball. Do I have the happy day? 2. Okay. And if I have a happy sunny day, I can do both swimming and pickleball. Do I have a happy day? Okay. So that's okay. That's okay. You work with 2 table here. Now, let me do the process again. If you want to do the 2 table, right? The first step here, you have to identify how many variables. If you have 1 variable, you have 2 rows. If you have 2 variables, you have 4 rows. If you have 3 variables, you have 8 rows. And you have the 4 variables, you have 16 rows. That's the first step. Now, the second step here, right? The second step here. See, you have to write the header column, 1 column for each variable, 1 variable, 1 variable, and 1 variable, and 1 column for the output here. Right? Okay, 1 column for the logical expression when I'm solving a problem here. Right? Now, for this one here, right? You have to follow the algorithm until you hit the last 2 or 4 alternative include column here, right? Now you see for the first one. For the first column here, top half is T, and the second half is 4. That's why I see the first one here. I have 8 rows, right? So the top 1, I have 2 here. The half of them, I have the 4 here. Right? I do the same process, and I move to the next column here. For each block of the consecutive T or 4 here in the previous column, right? Here's the next column with half T and half F. So see, I have 40 here. Again, I break it down into 2 halves. Right? I break it down into 2 halves. The first half is 2. The second half is a 4 here. Now I move to the third one. Right? The group of 2 here, again, I break it down. The first half is 2. The second half is a 4 here. That's the way I work with 2 table. Make sense? Okay. So basically, for the 2 table, you have to follow the process here. Right? You have to follow process when you do the 2 table. Right? You have to, the first step here, you have to determine how many number of row you need. Right? For each of them here, you have to write each column for 1 variable and 1 column for logical expression here. So basically, for this one, it should be better. I do with this one. Okay? I do with Excel here. Sun again. And logic. Right? And I have all here. And I have clickable here. Now, I work with this one here, right? I work with this one. So you see that I have 3 variables here, 1, 2, and 3 here. That's why I need 8 rows, right? I need 8 rows here. So I can draw it here, 1, 2, 3, 4, 5, 6, 7, 8. Right? Okay, so put it border here, and highlight the border. This one, right there. Okay, increase the 4 here. 40. Okay. So now remember, I have to, for the first column, right? For the first column here, I have to break it down in 2 halves. The first half is 2 here, 2. Right? I have 2, I have 2, I have 2, because you have 8 rows, right? That's why the first 4 is 2. The second 4, I have 4 here. The 4 here, I have 4 here, and the 4 here. Now, for the second one, right? For the second one here, remember that again. For each of the group here, you break it down in 2 halves again. You break it down in 2 halves again, right? So I have 2 here and 2 here, and I have 4 here and the 4 here. For the second one, right? You see, the first group of 2 here, right? I break it down 2 halves. 2 here and 2 4 here, and you do the same. I have 2 here and 2 here. I have 4 here and have 4 here. Now I move. Sorry, not this pen. This one. Okay. Now for the pickable also, right? You see, I move to the next one here. Alright. So for the group of 2 here, again I break it down 2 halves. 2, 4. Right? Group of 2 here, I break it down 2, 4. A group of 2 here, I break it down into 2 and 4. And group of 2 here, I break it down in 2 and 4. Now, in order to find out the output here, right? In order to find out the output here, that's the output. Here, happy day or not? Okay. So in order to find out, you have to work with the priority. You have to work with the order priority here, right? So in my program here, you know that is my program here. Where my slide? Yeah. My program here, it will be happy day. It is a sunny day, and I can swim or I can play pickleball here. The first step, you have to understand the problem already. Right? So basically, it is a sunny day, and I can swim or pickleball. You will be happy. Right? So basically, you see what happened here. Actually, I have to put some parentheses here. I have to do this one first. You know why? Because if you work the order of priority here, the not is always executable. And later on, you have and after that, you have or here. Right? Make sense? So if I do not here, if I do not put the parentheses here, you can see what happened here. Right? You can see what happened. It's a sunny day and the swim here, right? So it's a sunny day, yes. And the swim here, no. What happened? What happened? It's sunny day and swim here, no. What happened? You have 4, right? You have 4 here. So what is it? If I even that, I do not with the pickleball here. So what is it? 4 here, right? So I have the not happy day here. Right? But what happened here? If I have the sunny day, but what happened here? If I have the sunny day, it's a true, right? And I cannot swim. I have 4 here, but I can play pickleball. So what do you expect here? If I have the sunny day, it's true. I cannot swim, but I can play pickleball. What do you think? What is the output here? Sunny day. Cannot swim. I can go to the pickleball.
You expect it to be true, but
yes. If I do not use the parentheses here, you can see what happened.
Then it's still false.
Yeah, because what happened here? You have to do the and first. Right? So have 2 and 4 for sure. This one, the 4 here. Right? And you have all pickleball here, 2 here, you have 2 here. Right? Is that right? Am I confusing here? Okay, so see that's the one here. You have all here, that's okay. All here is okay. Now, not just good. Yeah, my mistake here. Now, do as this one. Nothing but this one. Right? If I don't do parentheses here, now I give you the example here. Alright, so I have sunny day and I can swim or can swim. Now let me do it with this one. If I do not use the parentheses here, if I do use the order operation here, you can see what happened. Right? Now think about this one. It's not sunny day. I have 4 here. Right? If it's not sunny day and I can swim here. You can swim, it's a 4 here. So we see, and here, 4 and 4, what do you have? 4 and 4, you have 4 here, right? But after that, I OR here. I OR with the applicable here, if I choose. So what is it? True, right? So in that case here, what happened here? It's not sunny day. I cannot go swim, but I still able to pick a ball. And the output here is true. It's not correct. Make sense? So basically, you have to understand from here. You know that you have to do this one as the first one. Parenthesis here. You have to do that first. Make sense? So now you can do it one by one here. You can do it one by one by the OR here, right? So you see the first step here. You need to do with. You need to do with one more step here, right? You have the pickable, swim, or pickable. Okay, you need one more temporary variable here. Now you can OR them together, right? And 2 and 2, what do you have? 2, right? And 2 and 4, what do you have? 2, because it's all here, right? 4 and 2, you have 2. 4 and 4, you have 4, right? 2 and 2, you have 2. 2 and 4, you have 2. 2 and 2, 4 and 2, you have 2. And 4 and 4, you have 4, right? Because for the output is only 2. At least one of them 2, right? So now you have to use this one. You have to use this one here. And you ending with this one. Make sense? That's the order of operation here. You have to do this one first. You use a temporary variable here, and now you end them. Right? So 2 and 2, what do you have? 2, right? Because it's ending here, right? 2 and 2 here, what do you have? 2, right? 2 and 2 here, what do you have? 2, right? And 2 and 4 here, what do you have? 4, because it's AND logic, right? You have AND logic here. You have 4. 4 and 2, you have 4. Right? 4 and 2, you have 4. And 4 and 2, you have 4. And 4 and 4, you have 4. Right? Is that correct? Okay, so see, you can translate it here, right? If it's sunny day, right? If it's sunny day, it's sunny day and I can swim and I can do the pickleball. For sure, I have a happy day, right? If it's sunny day here, I can swim, but I cannot do the pickleball. I still have a happy day, right? And if it's sunny day here, this one here, right? I cannot swim, but I can do the pickleball. I am happy day here, right? If it's a sunny day here, but I cannot swim, and also I cannot do the pickleball, I have not happy day, right? And if I have no sunny day, for sure, they are not happy day. Make sense? So basically, in order to do with this problem here, the first step, you have to make sure you understand the problem, right? You submit step here, you have to for sure you understand the problem correctly here, right? You have to understand the problem correctly. What am I? Yeah, right? This one. Right? So basically, you have to understand problem. You have to identify the swim or pickleball first. You have to practice them together, right? And after that, you do with the end sunny day here, right? If you do not sum in the order, you have the correct output here, because whenever you have the not sunny day here, you know, and support here, right? You see, in the case if you do not use the parenthesis here, right? If you do not have parenthesis here, see, if you have the 4 and you have 4 here, the output of the end you have 4, but after that you all here 2 here, right? You have the 2 here. Now let's do some of the truth table here. Now let's do with this one. Think about I have the not A and B and or C here. Now let's do it. Let's do the truth table here. Open Excel and do it. Now the first step here, you tell me how many variables you get. Three, right? A, B, C here. Okay, so you need 8 rows for that one. And remember, you use a temporary variable also, right? And the order of operation here, you should know the order of operation, not first, right? Only not first. After that, you use and after that, you use or. So for the order of operation here, they always execute not first, right? Then and or here. Okay, so the first step, right? The first step, I just do it with the three variable here. I use the table first, right? So I have the 8, right? I have 8 here, not 9, right? So the half of them true, true, and I have 4. I have 4, I have 4, 4, right? And I move to the second variable. Every consecutive here, I break it down up, right? So that's why I have 2, 4, 4, 2, 2, 4, and the 4 here. Now I move to the third variable. Every consecutive 2 here, again break it down to half, right? That's why I have 2 here, I have 4 here, I have 2 here, I have 4 here, I have 2 here, I have 4 here, I have 2 here, I have 4 here. Now, if you look into this one, right? If you look at this one, the order here, right? The order here, right? You have to do the not I first, right? So 2, I have 4. 2, I have 4. 2, I have 4. 2, I have 4. Right? 4, I have 2. Not 2, 2, 2. Right? So now I have this one. Right? I have this one temporary here, so I can work with this one here. I can put this one. Now I need to do the AND, right? I need to do the AND here, so I do the AND with B here. So I do the AND with B. I put it here. Now I can put with another one here. Right? I can put with not A and B here. Okay, so now I have to do it, right? So 4 and 2, what do we have? 4 and 2, what do we have? Yeah, because the N is all right. 4 and 2, I have 4. And what is this? Right? Okay, now 4 and 2, I have 4, right? 4 and 2, I have 4. 4 and 4, I have 4. 4 and 4, I have 4. 2 and 2, what do I have? 2, right? Because and here, 2 and 2, I have 2. 2 and 4, I have 4. 2 and 4, I have 4. Make sense? I do this one here, right? This one I do the OR here, right? 4 and 2, what do we have? What do you think? 4 and 2. This one here, right? 4 or 2, sorry, 4 or 2. What do we have for output? 2, because at least one of them 2 for the OR is 2, right? So I have 2 here, right? I have 4 here, I have 2 here, I have 4 here, I have 2, I have 2, I have 2, I have 4 here. That's all. That's what I did with this one. Make sense? You guys got it? Is correct or not? Yeah, check with your work here. Is correct or not? Now I move to the second one. The second one here, right? The truth table for A and B obviously here, right? So basically, I do the same process, right? I have A and B, right? XOR here, I have C, right? So now I do the first process here. Also, I have to do the same. Right? I have to find out. I have to figure out the correct 2 and 4 first. Right? Put it here. Do the same process here. Right? So now, half of them 2, 2, 2, 2, 4, 4, 4, 4. Now move to the second variable. Every consecutive block here, again, break it down into half, right? So I have 2, I have 2, I have 4, I have 4, I have 2, I have 2, I have 4, I have 4. Now move to the C here, right? Every previous group of 2 or 4, I will again break it down to half. So that's why I have 2, I have 4, I have 2, I have 4, I have 2, I have 4, I have 2, I have 4. Okay, so now we know that for this one, right? For this one here, you have to execute everything inside the parentheses first, right? You have to do everything inside the parentheses first here. That's why you have to figure out this one here, right? This one, B, X or C first, right? So now, what is it? 2 and 2, what do we have? For X or here? Either, you know that either, only one of them, right? So both of them, sorry, both of them 2, you have 4. Either, right? That's why you have 4 here. Only one of them. That one 2. That one 2. That one 4. That one 4. That one 2. That one 2. And that one 4. Right? Okay. And now you have. Now we do them together. Right? A and B, X or C here. Right? Now do it here, right? I want to do with this one. And I want to do with this one. And I use N here. Right? So now 2 and 4. 4, right? 2 and 2, I have 2 here. 2 and 2, I have 2 here. Right? I have 2 and 4, I have 4 here. Right? I have 4 and 4, I have 4 here. And I have 4 and 2, I have 4 here. I have 4 and 2, I have 4 here. And I have 4 and 4, I have 4. That's all. Understand? Is that correct? 2 and 4, 4. 2 and 2, 2. 2 and 2, 2. 2 and 4, 4. 4 and 4, 4. 4 and 2, 4. 4 and 2, 4. Is that correct?
I thought the V was or.
Which one?
Or like,
Huh? This one, oh, sorry, right? Oh, my mistake here. Sorry, I missed that. No, sorry. Yeah, so basically this one, or here, right? Yes, sorry for that. I read it incorrect here because this one is or, right? Okay, so we have the 2 and 4. Sorry, and 2 and 4 here, you have 2, right? And 2 and 2, we have 2. You have 2 and 2, you have 2. You have 2 and 4, you have 2. You have 4 and 4, you have 4. You have 4 and 2, you have 2. You have 4 and 2, you have 2. And you have 4 and 4, you have 4. Right? Okay, sorry. I think it is N here, but actually it's all here. Okay, that's all. That's the process. In some case, you have to use the temporary variable here. I think about in that case here. In this case, you have to figure out this one first. Right? You can use a temporary variable here. And in that case also, you have to use a temporary for not here, and you also have the temporary for N here. Okay? That's the process here. Okay, so what time is it? So yeah, that's the case. You work with the two table. That's the some of the process here. Then remember, whenever we do the process here, right? You have the one column for the first step here. The first step here, you have identify how many rows here, right? You have to identify how many rows you need here. One variable, 2 rows, 2 variable, 4, and so on here, right? The second step, yeah, you break it down into write a header column here, right? One column for each variable and one column for logic or expression you are over here. Right, and again, you just follow the algorithm below until you hit the last 2 or 4 alternative column here. The first column, right? The top half is true and bottom half is false. And you move on to the next column here, and so on. Right? Okay. So I think that's all for today. I don't have any activity for today, but you expect that you have more on Wednesday. That in Wednesday you work with your truth table and you work with the logic gate also. Right? Okay. So I see you guys on Wednesday. Any question? Let me know. Any question? Okay, so make sure you download and install the logic simulation in your computer. Do some of the activity. Yeah, I don't get. Okay, so see you guys on Wednesday. Bye bye.
Thank you, sir.